Good morning and good afternoon. Welcome to Cummins Power webinar series, the program designed for our engineering partners like yourselves. This program will offer concise technical presentations on topics pertaining to on-site power system design and specifications. It's meant to keep you updated on products, technologies, codes and standards, developments, and the topics most relevant to your jobs and projects you're working on. You're going to be able to interact directly with the Cummins presenters throughout the Q&A sessions at each of our live webinars and gain access to ongoing technical support through our post events. This webinar will be recorded and archived. If you happen to miss a webinar, visit our Demand Webinar Center in PowerSuite and replay any topic of your interest. You're also going to be earning one professional development hour issued by Cummins upon your completion of the webinar. My name is Tom Bakritzis. I'm your Cummins facilitator. I'm the Global Sales Training Manager for Cummins. Today our presenter is Mike Sanford. He's a Sales Application Engineering Leader for North America for Cummins. And with that, Mike, please start your presentation.
Great. Thanks, Tom, for the introduction. So we are going to cover understanding ISO generator set ratings today. And I'm going to walk you through the different things that we're going to be talking about through the next hour. We're going to spend a little bit of time talking specifically about ISO 8528 generator set ratings. We're also going to talk about ratings that go above and beyond ISO, what we refer to as industry adopted ratings that may be developed by different generator set manufacturers in order to target a specific market or a specific segment. We'll spend just a very brief period of time talking about EPA regulations and how they relate to the ISO 8528 ratings. Lastly, we'll wrap up talking about alternator thermal ratings and again how they relate back to those ISO 8528 ratings. So let's go ahead and get started here. One of the first things I want to start with is talking about the way that generator set manufacturers configure products in order to develop different ratings. And what I'm talking about here is you may see a generator set manufacturer that offers a single engine or one engine platform that is actually paired with one alternator, and the result of that configuration may yield one particular generator set rating. Now likewise, that same alternator at a different temperature rise, as we'll be discussing later on, can be used to yield a different generator set rating. So you may have two ratings based on the same engine and alternator. Likewise, a second alternator may be used with that same engine, and a third or even fourth rating could be developed. Add in combinations of other engines and alternators, and you can see how a generator set manufacturer can line up their entire product portfolio in order to cover a wide range of ratings with a limited number of engines and alternators. And again, we're going to talk about the way these ratings are intended to be applied and also dive a little bit further into these alternator ratings and how those help to direct us to different usage cases. So what you're seeing on the screen now is an example of a generator set data sheet. I just wanted to point this out to show that this one particular model, the C3500D6E, is actually published with three different ratings. It includes a standby, a prime, and a continuous rating. That's pretty typical for most generator set manufacturers to offer a single generator set model with a wide variety of ratings covering generally all three of the main ISO ratings. So moving forward, talking specifically about ISO 8528. It's important to understand that ISO 8528 is a reference standard for reciprocating internal combustion engine driven alternating current generator sets. And what that means is as a reference standard, it's not a governing standard. It's not law. It's typically not adopted by law or even local law. However, it may be used as a reference for engineers in order to be able to compare different generator set manufacturers' products with one another. It allows you to effectively compare apples to apples. And so one of the things that's defined within ISO 8528 are the different generator set ratings. And actually, you're probably most familiar with standby, prime, and continuous. ISO 8528 actually breaks down into four different categories. One being ESP, or emergency standby power, limited time prime power, or LTP, prime rated power, PRP, or continuous operating power, COP. So over the next few slides, we're going to go a little bit further in depth on what those individual ratings mean and how it's best to apply those. Lastly, kind of before we wrap up the rating conversation, we're going to talk about those ratings adopted by the industry and adopted by different generator set manufacturers that are intended to target a specific market, customer base, or segment. So one of the things I'll kind of start with when talking about these ratings, you'll see that each rating really is intending to drive towards a particular application. There are different things in here that may help you to decide which rating is best for your particular usage case. One of the biggest ones that I'll point out, you'll hear me talk about it quite a bit, is the annual generator set runtime, or the expected annual generator set runtime. One of the other big things is talking about the load type, whether it's a variable, whether it's a constant load. We'll also talk briefly about negotiated contracts, and really what I'm talking about here is anything that would potentially be considered revenue generating. And last but not least, warranty. At the end of the day, it's important to understand that ISO 8528, although adopted by many generator set manufacturers, most generator set manufacturers are willing to and do go above and beyond as far as standing behind and warranting their products. So again, it's a good baseline in order to be able to compare generator set ratings, but it's important to understand what an individual generator set manufacturer is actually offering when they tell you their product is standby, prime, or continuous rated. So the first one I'll talk about here, and this one you're probably most familiar with, that's emergency standby power, ESP. Emergency standby power is for supplying emergency power for the duration of the utility power failure. However, its expectation is it's not to exceed 200 hours a year. So it's important, again, important to understand that just what I was talking about in relation to warranty. The expectation from ISO is that this typically is not used for more than 200 hours a year, there's an understanding that this is intended for usage during emergency applications that may exceed that timeline. So again, make sure to work with your generator set manufacturer to understand what that means for your customer. The other big thing to point out here is the average load factor expectation. ISO sets a minimum, maximum, so a maximum allowable load factor over a 24-hour period of time is 70%. And what that means is if you have for example, a 1 megawatt generator set, the average load on that generator set over 24 hours is not intended to exceed 700 kilowatts. That's the expectation from ISO. So to walk through a couple of different applications, again, you're probably familiar with these. These are going to be emergency, whether that's an NEC, life safety, or critical. But the other big one to keep in mind is, of course, optional. So this may be not legally required to have a generator set or alternate power source on site, but you may want it for perhaps financial reasons. Again, a data center outside of its egress requirements may still want generator sets on site in order to minimize downtime, and that would still be considered emergency standby power, or ESP, under ISO 8528. So you can see a couple different examples of both a healthcare facility and a data center in various locations around the world employing this particular rating. But again, this extends all the way down to your consumer residential product as well. The next rating I'll talk about here is limited time prime power, LTP. You may be somewhat familiar with this rating, as most generator set manufacturers publish or market just a prime rating. And what limited time prime power is intended to serve is kind of a niche market, and really it's targeting up to 500 hours per year is the expectation from ISO, but it's intending to serve a non-variable load, so a constant load at 500 hours, or up to 500 hours per year, and up to a 100% load factor. It's really expecting to be running flat out for that period of time when it is running. Again, this could be something like a peaking or even a rate curtailment, could even be a grid support in some situations. So you can see a couple different examples of limited time prime applications here. Again, this is a pretty popular rating when used for power plant applications, again, especially those that are base loading or rate curtailment. One of the things to keep in mind, I'll talk a little bit about the EPA later on, but it's important to understand that a limited time rating can be applied without having to go to more stringent emissions requirements. However, the EPA won't allow the operation while the utility is present. So just understand the difference between the two, and again, we're going to go through that a little bit further in depth here in a few moments. So So the next rating I'm going to talk about here is prime rated power. Prime rated power you may be familiar with. This is intended to operate for up to 8,760 hours a year. That's a full year. It's intended to be a variable load, and again, similar to standby, it's intended to serve not greater than a 70% average load factor over a 24-hour period of time. Some of the reasons you may use this is one of the big ones is a facility where you don't have a utility source of your own. So a remote mining site, for example, who doesn't have utility power available is going to be relying on generator set power 8,760 hours a year. However, more than likely it's going to be a variable load as different equipment turns on and turns off. Likewise, we see things like crane applications using prime rated power generator sets in order to serve the unique load profile of that particular application. Again, understanding that this is separate from the EPA expectations for usage. This last rating I'm going to talk about here is continuous operating power, COP. Continuous operating power, similar to prime rated power that we just talked about, is really intended to operate 8,760 hours a year, around the clock. However, the big difference is this is tending to run at 100% of the generator set's rating every time it runs. So again, this is going to be things where you may be base loading, where you want to limit the amount of power that you're importing from the utility. You may also have another reason or another opportunity for running the generator set, something like combined heat and power, where you're using generator set excess heat to generate steam or other needs for the facility. So that actually wraps up the ISO 8528 ratings themselves. I'm going to spend a little bit of time here talking about some of the different industry adopted ratings. One of the first ones I'm going to talk about is become increasingly popular amongst generator set manufacturers are ratings that are intended to serve the data center market, and particularly looking at Uptime Institute compliance. For those of you who are unfamiliar with Uptime Institute, I'll give you a brief background here. The Uptime Institute is a third-party organization who has developed a kind of criteria for, you could call it grading a data center to determine or estimate its uptime potential, its reliability. And really what uptime is driving towards is increased reliability. That's the goal in order to ensure that the data center is capable of achieving high levels of uptime. There's 4 different tiers, unfortunately mirroring the EPA tiers, but again, important to keep those different. 4 different tiers, 4 being the highest or expected highest uptime, and 1 being the lowest. It's important to understand why someone would even want to achieve this. And one of the big things, one of the big users or customers of Uptime Institute is going to be data centers who are offering up their services to other customers. So what we typically refer to as a co-location data center versus, say, an enterprise data center. And what this allows them to do as a data center owner and operator is allows them to achieve a level of uptime indicated by their tier ranking and market that to their potential customers and say, hey, we're a tier 3 or tier 4 data center. You want to use us because we have higher levels of uptime than maybe some of our competitors. It's important to understand that power generation is one of 16 different subsystems that are evaluated. And so one of the questions that typically comes up is can a generator set be certified? And the answer would typically be no. A generator set itself is not a certifiable uptime solution. It's a whole package. However, we'll talk about some of the things that Uptime in particular may be looking for. So one of the things as you work through uptime compliance, as you move towards a tier 3 and tier 4, so again the higher levels of tier certification, there are some more stringent requirements for the on-site power generation. In fact, Uptime specifically says that disruptions to the utility power are not considered a failure, but an operational condition for which the site must be prepared. So what that's saying is you can't count on the utility. You can't count on it being there, and you don't get to count it as a failure. So with that in mind, it would only make sense that it would be a requirement or an expectation that a data center operator or owner who's seeking Tier 3 or Tier 4 certification needs to be able to generate all of their power on site. If you can't rely on the utility, you need to be able to generate all of your own power. Furthermore, if you're relying on all of your own power and you're never counting on the utility coming back because you weren't counting on it to begin with, the generator set, so the alternate power source, can't have any limitation on its hours of operation or its runtime. If it did, it wouldn't meet the needs of the data center for uptime compliance. So you can see here, if you look at these things and you look back at those ISO ratings that we talked about, you'd probably notice that the only rating that really makes any sense here is continuous operating power. It's the only rating that is set for 8,760 hours a year. It's set for continuous load at 100% load factor. The issue with that, as you can imagine, is it may drive towards a generator set solution that may be a bit oversized. And what I mean by that is a continuous rated generator set is built to run 8,760 hours a year at full load, when in reality, we understand and Uptime understands that for the most part, data centers aren't being built somewhere where the utility downtime or where the utility actually isn't present, right? You're not actually running on generator set power 8,760 hours a year. In fact, generator set usage at a data center, studies have shown that typically it's at or below 30% of the generator set's rating. And so the issue here is that when you underload a generator set to that level, it can actually drive towards a solution that has increased maintenance concerns, and we typically refer to that as wet stacking on a large underloaded diesel or compression ignition generator set. And again, when we're talking with Uptime, their goal is to help facilitate data centers that are more reliable or have better uptime. And so again, you can see that there's kind of a conflict there. And so what you're looking at here on the screen is an example of a data center continuous rating that's available and been published in the industry. And what this does is it drives towards a solution that mitigates this wet stacking or these increased maintenance concerns and yields a better solution for Uptime Institute compliance. And so again, the key here is that data center continuous is the maximum power which the generator set is capable of delivering continuously to a constant or varying electrical load for an unlimited number of hours in a data center application. The big watch out here is there are some data center continuous ratings published by different manufacturers. Now again, I'll take a step back for a moment. This goes above and beyond ISO, so it's up to generator set manufacturers to market this as they see fit. And so some generator set manufacturers have included verbiage in their definition that says something like where reliable utility power is available. Well, if you remember the last slide, I just covered the fact that Uptime doesn't view the utility as a realistic alternative, or it's an economical alternative, but you can't count on it as your primary power source. And so we actually would say that any rating that includes this verbiage or verbiage similar actually would meet the Uptime Institute requirements. The other thing I'll mention real quick is there are going to be a couple upcoming power hours on the topic of generator ratings for data centers as well as generator set features for data centers. Just keep watching out for those. Those of you who are subscribed will of course get more information on those as they come up. So moving on here, what you're looking at is just a quick example of one particular generator set model, and I just wanted to show you the way the different ratings kind of stack up against each other. And so what you're looking at here is you're looking at in the red column indicating the full rating, so that's 100% of the generator set's rating. In the darker column, what you'll see is the maximum 24-hour average load compared to that full rating. So for example, you're seeing prime rated power there in the second two columns. You have 2,500 kilowatts is the full rating. 70% of that is 1,750 kilowatts. Down in the bottom in yellow, you're then seeing the maximum anticipated operation on an annual basis, highlighted in particular for standby. and limited time prime. However, prime rated power, continuous, and data center continuous have no limitation on their annual runtime. This next slide here is showing the same information, just in a slightly different format. Again, you'll have this Power Hour available to you afterwards, and this may be a good reference for you in the future. So one of the next things, we'll pause here and get some feedback from the participants. Based on the application shown, which ISO 8528 generator set rating should be selected? And I'll give you a moment to think, but I'll clarify here. What you're seeing is everything below this red line is what's being provided by the utility, and everything above it is being provided by the generator set. So again, don't worry about EPA, just think about what we talked about in relation to emergency, prime, limited time prime, and continuous operating power. And you can go ahead and submit your feedback in the WebEx. So,
great. All right, everybody. As a reminder, go ahead and please send in those answers. It's a multiple choice question, and go ahead and see those coming in. All right. It looks like we will give you another couple seconds here. Perfect.
Great. Looks like good feedback. I appreciate everyone's participation there. So I think everyone pretty much got it. We would typically refer to this as a prime application. I saw a couple that indicated limited time prime power in there, and the difference here is understanding that the prime rated power is intended to serve a variable load, and you can see that that generator set power would be variable in this case as it goes up and down, whereas limited time prime is typically going to be serving only a continuous load. So once again, thank you for your participation. So moving forward, I'm going to cover a couple different watch-outs here in regards to those ISO 8528 and other industry-adopted ratings. One of the first ones I'll point out is parasitic losses. Although ISO 8528 specifically calls out that all losses should be accounted for in the rating, not all generator set manufacturers publish ratings accordingly. One of the big ones being cooling systems. So for example, if a generator set manufacturer were to say that a generator set has a published rating of 3350, so 3,350 kilowatts. However, the cooling system isn't accounted for. On a generator set of that size, that may be a 100 kilowatt cooling system. That's a significant chunk of load there. The result is that the actual load available to the customer drops by that same amount. And so the actual available customer load is going to be about 3,250 kilowatts in this case. So just make sure that when you're comparing products across manufacturers that you're receiving the same product from both. The next thing I'll talk about here is the site impact on ratings. Both altitude and ambient may impact the available customer load, and it's important to understand that different generator set manufacturers adopt different standards or a different reference for where their ratings begin, and I'll show you an example of that here. What you're looking at here is a chart depicting the altitude performance of two different generator sets manufactured by two different generator set manufacturers. The red line indicating manufacturer A and manufacturer B, and we're assuming that the temperature is constant across these. What you're looking at is what we refer to as the knee point, or the point at which the product starts to have its performance impacted as a result of the altitude. And so in this case, manufacturer A's product isn't impacted by altitude until about 1,000 meters above sea level. On the other hand, manufacturer B's product starts to be impacted around 500 meters above mean sea level. What this means is that if your site is at 900 meters above sea level, and you are comparing a product from manufacturer A and manufacturer B, manufacturer A's product is going to have no D rate. So if it was a 2,750 kilowatt generator set, it's still going to be rated for 2,750 kilowatts at 900 meters. On the other hand, manufacturer B's product in this case is going to drop to about 2,200 kilowatts, or about 20% loss in power at this site. So again, just make sure that when you're comparing those products that you're receiving the same type of information from both manufacturers. Okay, I'm going to step out from ISO 8528 here. I'm going to spend a little bit of time talking about the EPA usage categories. And really, the real reason I want to stress this is to understand that there's isolation in ISO and EPA. They're not necessarily directly linked. You might say that there's some overlap, and I'll talk about that, but one doesn't necessarily drive the other. One of the first things I'll mention is that EPA regulates engines, not generator sets. And it regulates the engine based on the actual usage and the horsepower of the engine. So for example, an engine that doesn't move, a stationary engine, can be certified either emergency or non-emergency. And what that means is it's either operating only when the utility fails, so that would be emergency, or non-emergency, basically meaning it can operate whenever you want it to, even if the utility is present. Non-emergency operation is going to be much more heavily regulated as it has the potential to run more often. Likewise, non-road certified products are also susceptible to higher or more stringent emissions requirements, again, as they follow the same non-emergency usage expectations. The difference here between ISO is that it's actually appropriate to apply a prime-rated generator set into, for example, an EPA stationary emergency application. And the usage for that may be somewhere where the product is only intended to be used when the utility fails, and it's not going to move. That would be stationary emergency. However, because of maybe low utility capability in that region, the usage is expected to exceed 200 hours a year. It's not extremely common in the United States, but there are certain areas, particularly remote areas, where this may be the case. So again, that would actually be appropriate to apply that way. But typically in North America, we typically see ISO standby paired with EPA stationary emergency. So real quick, we'll run through just another check here to make sure everyone's following along. If you're the owner of a new facility that requires generator sets for the sole purpose of providing emergency backup power for the utility, the annual utility outage is expected to be around 20 hours a year with a variable load profile. Which ISO 8528 generator set rating and EPA exhaust emissions designation should you select? I'll give you just a minute to review these and think about what we had just talked about.
Okay, everyone, you have a choice there, multiple choice, A, B, C, or D. Go ahead and put that in your Q&A session, and we'll wait a few more seconds for everybody to reply. And a lot of responses, Mike.
Great, looks good. Okay, wonderful. Thank you all for your participation. So we would typically refer to this as emergency standby power in the stationary emergency application. So again, the expected usage is less than 200 hours a year, and it's only being used to back up the utility. We did talk about some examples where we might be using a ISO prime rating with the stationary emergency, but in this case, we would still be using just the standby. Thank you again for your participation. So wrapping up, I'm going to talk a little bit here about alternator ratings. So it's important to understand, from the very beginning, we talked about the fact that generator set models, multiple models may be based on a similar engine platform, or even the same engine platform. Similarly, generator sets may be offered with multiple ratings based on alternator, even cooling system configurations. Lastly, the alternators can be changed in order to reach different varying voltage configurations as well as different temperature rise, and I will talk about that here in just a moment. So what we're talking about here, and here's a great example. This is one particular product, the C3500D6E, with three different ratings. We talked about 3,500 kilowatts, 3 meg, and 2750 at the beginning of this course. On the right-hand side, what you're seeing is actually 5 different alternator options that could be used to achieve any of these ratings. Now, if you look at that first alternator options, that HVSI 804W, you'll see that at a given temperature rise, it's only rated for about 3 megawatts. In that case, we certainly couldn't use that in order to reach that standby rating of 3.5 megawatts. So more than likely, that rating is used, or that alternator is only used at the lower power nodes or at the lower ISO ratings. On the other hand, at the very bottom, looking at that DIG 142F alternator, it's rated for almost 4.3 megawatts. Clearly, oversized, definitely capable for supporting that ISO standby rating at 3.5 megawatts. So the next thing I want to talk about here in regard to this is really what we're talking about here is in regards to the temperature rise is looking at the operation temperature allowed by the insulation material within the winding. And typically what we're talking about, this is typically communicated in terms of temperature rise. And so what you're probably familiar with hearing is it's an 80 degree C alternator, it's a 105, it's a 125 degree C alternator. What that means is at a particular voltage and kilowatt rating, the internal temperature rises a set amount. And I'll walk through an example here. So this is a snapshot of an alternator data sheet, and we're going to focus primarily on the 480 volt section here just for this example. And so what you're seeing is at 480 volt, this alternator actually has 5 different ratings: 163, 150, 125, 105, and 80 degree C temperature rise ratings. And what you're probably noticing is down at the bottom there, at 80 degrees C, it's rated for only 1,920 kilowatts. On the other hand, at 163 degrees, it has a much higher rating. And so again, what we're looking at is the fact that as more power is being pulled from that alternator, as you're asking the alternator to do more work, the internal temperature is rising more and more. And so again, we'll walk you through this here. If you were to ask the alternator for 25 or 2.5 megawatts, the internal temperature would rise about 150 degrees C. On the other hand, that 80 degree C temperature rise is going to yield about a 1900 or 1.9 megawatt rating. And really the difference here is going to be the expected life of the product. Again, as you can imagine, when operating at 150 degrees C as opposed to 80 degrees C, the overall life of the insulation is probably going to be lower. And so what we would typically see is the lower temperature rise ratings, 80, 105, and even 125, used in more continuous or prime applications, whereas 125, 150, and 163 may be used in more standby-like applications. So just wrapping up here, what you're looking at is just a quick example or a quick summary of both the ISO ratings as well as the alternator ratings shown below. So again, this should be a good reference for you in the future. With that, I am going to go ahead and wrap up. Again, it's important to, we talked about the importance of selecting the appropriate generator set rating for the intended use, load profile, and hours of operation. We talked about really what ISO 8528 is and how it works within the industry. We also talked about ratings, industry adopted ratings that may go above ISO 8528. We talked a little bit about the EPA ratings and how those ratings differ in some cases from the ISO ratings and how there may be a little bit of overlap, but how they're isolated standards. And lastly, we talked about alternator thermal ratings and their impact on both the alternator performance as well as the insulation life. And with that, I will turn it back over to Tom, and I believe we'll open up for Q&A.
Yeah, great job as always, Mike. I appreciate it. As a reminder, everybody, please type your questions, comments, feedback into the WebEx Q&A box. We can get to as many as possible. If we don't get to all the questions, we'll also be publishing a consolidated FAQ list along with the presentation and the recorded webinar on powersuite.cummins.com. You're also able to connect with any of your Cummins contacts in your region. Go ahead and look at that list. We'll be providing that list afterwards as well. So with that, let's get to some of the questions, Mike, as they're coming in. So first question, do your products, gensets, have an Uptime Institute certification for data centers?
That's a great question. It's something we talked about a bit early on. One of the things that I'd like to remind everyone is, again, the Uptime Institute doesn't certify generator sets in particular. However, there are different generator set manufacturers who provide ratings that may be pre-approved or that have worked with Uptime in order to develop those ratings. So again, the big key being the constant load, the no limitation on run hours, and the no limitation on an average load factor, and of course, no requirement to have a reliable utility on site.
Excellent. Mike, can you remind us what a KWE is?
Oh, sure. Sorry for not clarifying that earlier. KWE typically used to designate kilowatts electrical versus kilowatts mechanical in order to, again, just differentiate between the engine power and the actual electrical output of the generator set.
Next question, Mike. When in altitude derate condition does fuel consumption change?
Great question. So we talked about the impact on the generator set itself, or on the output of the generator set based on the altitude. And really what we're talking about there in particular is the change in air density. As air density decreases, it's harder for the engine to make full power. And so there's a certain point where the density has changed so much that the engine can't force enough air mass or air mass into the cylinders in order to achieve the same level of power. So to answer the question about fuel consumption, certainly there's going to be an impact on fuel consumption. However, typically you're going to see a bigger impact on the output of the product before that occurs.
Awesome. Next question. What changes are made to a generator set in order to make it rated fully single-phase output?
Good question. So typically what we're seeing, or what we see many generator set manufacturers do in order to achieve a full output on the generator set in a single-phase configuration, is typically an oversized alternator in order to accommodate the single-phase loads.
Okay. Next question, Mike. In ISO 8528 ESP or PRP has a 70% average load factor. Does this percentage vary by manufacturer or model?
Great question. To reiterate, ISO's expectation is that the lowest number that a manufacturer can adopt is 70%. So manufacturers can, in some cases, do adopt higher average load factor ratings. And that's where it's important to understand that although ISO sets the standard, different manufacturers may go above and beyond. And so again, it's best to work closely with the generator set manufacturers or suppliers who you're considering in order to understand what it is specifically that they offer on their products, what they will warranty, and how that compares to some of the other products on the market.
Good. Some more questions coming in. Keep sending in those questions. Really appreciate it. Next question. Is there an alteration of EPA emission regulations anticipated? Are you seeing owners being less proactively going to Tier 4 final in anticipation of regulatory relief?
Good question. So I'll say from my standpoint, I'm not seeing, or we're not seeing anything on the horizon right now that's indicating regulatory relief is incoming. There have been some things that have changed in regards to, say, Tier 4 final. So again, I talked about it very briefly, but for non-emergency, stationary non-emergency and non-road, for compressor ignition, everything today is on Tier 4 certified. One of the things that we did see recently was the addition of inducement mitigation in order to bypass inducement for emergency applications. However, as far as an overwhelming or an overall relief or change in regulation, no, I don't see that on the horizon.
Okay. Got an interesting one here. How does a lower temperature rise alternate correlate with motor start capability?
Another good question. So let me talk about that a little bit. So I talked earlier about the temperature rise ratings and how a 150 degrees C alternator rated alternator will allow you to pull more power from the alternator. Let's call it 2,500 kilowatts. That same alternator can only pull 1,900 kilowatts at 80 degrees C. If you need 2,500 kilowatts and you need a lower temperature rise rating, you can't use that alternator. You have to use a bigger alternator. And so there isn't a I wouldn't call it a causal link between alternator temperature rise and motor starting capability, but what you're doing when you're specifying a lower temperature rise is you may be inadvertently driving up the size of the alternator, which in turn may impact things like motor starting capability. So generally speaking, I would say yes, a lower temperature rise will more than likely yield increased motor starting capability. But again, it's not, I wouldn't say it's causal, it's kind of an indirect link there.
Okay. Keep sending those questions. I think we're going to be able to get to one or two more questions in the time that we're allowed here. So, Mike, are the ISO ratings tested or theoretical?
Ooh, that's a great question. So I'll talk about this here just a minute. It's important to work with the generator manufacturer to understand what they're doing in order for testing. What we really like to see and really recommend seeing, and even NFPA, not going to talk too much about it here, but also goes on to talk about prototype testing and to encourage generator manufacturers to conduct prototype testing. And so certainly we'd expect that most generator manufacturers are, of course, testing their ratings in order to ensure that the product can perform as expected in the field. So looking for things like a prototype test certificate or prototype test summary might be helpful for you to understand what has been tested by the generator set manufacturer and to understand what they've done in order to make sure the product's going to work for you.
Awesome. I think that will probably be the last question. And with that, everyone, we really appreciate your attendance. Please watch out for an email including a link to this webinar recording, a PDH certificate, and then we're going to include a 2-minute survey link. Tell us how we did and how we can improve. Also, please visit powersuite.cummins.com for the recording, presentation, and FAQ, and other Cummins continuing education programs. You'll also be able to find a sizing and spec development tool. So as always, everyone, we appreciate your attendance. Look forward to your next participation, and